This new addition. We never operated that band as EME, and right away we are moving to the Eve project using the same band. Using this band, it's been already successfully accomplished by German amateur radio group back in 2006 when they got reflection of Venus, but they use a lot high power than we trying to build the amplifier and different type of modulation. And obviously, the frequency was slightly different than our amateur radio. So this is what you see. It's a mini circuits palettes that only available palettes that we can use to build the amplifier system. When I'm saying amplifier system, I'm talking about combining power for a number of the pallets. Our goal to achieve a legal limit on 13 centimeters, which is the 1500 watts per FCC. We're gonna use that power to generate a very powerful beam of the electromagnetic wave um, and to overcome this enormous amount of losses on 13 centimeters to get reflection. So I started building the prototype to make sure that the palettes are suitable of what we're trying to achieve. The reason why we were doing this because these commercial palettes, they're rated to 2.4 to 2.5 gigahertz, not quite for amateur radio band. So the concern was if they are capable of delivering on the power. And after numerous of bench tests, this is another view of the pallets. Pallets came separate out of the heatsink, so I had to assemble all together, put the PWM controllers for the fan. As you can see, this pallet is quite generates heat, so it would need to have a very good forced cooling system. And each pallet produces about 250 watts power. So we're looking to build the amplifier system with 8 pallets combined to get approximately between 1600 to 1800 watts. They have a little bit more in the budget to overcome the expected losses between the amplifier and the feed. This is prototype of 2 pallets and 2 power supplies that been used for the bench test successfully.
Uh,
This is a short video of the system running and everything quite looks good. I'm using the Kuni transmitter to generate the signal on 2.3 gigahertz. Very low, about 1 watt, enough to get 220 watts. It's the output power from individual pallet. With combined power, it's about 400, 420 watts out of 2. This is the bench test of the amplifier system. So I'd say the system being successfully tested and verified. Sorry, I guess I need to close my office. It's been successfully verified. So from engineering standpoint view, I am confident that moving with 8 pallet system will we will be able to generate at least 1600 watts, which we needed for the EVE 26 project. So this is not the final assembly. Once again, it's a bench test prototype. It's the so-called proof of concept. In actual assembly, we would have different approach. We would have splitting signal into 8 directions, and then each signal line would have amplifier, and then we're gonna combine those 8 pallets into the using into the one output using the 8-port combiner. So these are the specially designed for DSES for EVE 26 effort, high power LNA. When I'm saying high power, they're rated for the high input power. We faced a problem during EVE 25, even though we had good isolation between transmit and receive. The amount of power being generated and also reflecting power off the surface of the dish comes back to the feed that reduces the isolation. Our preamplifiers that pre-sensitive without good sufficient dynamic range was basically blown up and damaged. So we decided to have different approach. In this case, design the special LNAs that have can accept almost 20 watts on input without being damaged. They have built-in relay of the isolation circuit, and this SMA connector sticking on the side is actually for the load. So in case of the signal from get coupled back to receive port, it goes sync to the terminator of the 50 ohm load. Because of the power amplifiers from mini circuits are they the way had to design they have I2C communication line, and those circuits are not exist, so we have to design our own I2C controller, which will give us fully remote telemetry. This is the concept, as I already mentioned before, how we're planning to combine signal. Currently, we're looking at W6PQL. Is anyone familiar with that? Those are combiners and splitters, and they made from the Rogers material. Nothing to do with the W3 mix, but it's a material that's very low loss material, way better than FR4. So this is how we're gonna create 8-path signal separation. Because we splitting the signal and combining, there would be no combining and splitting loss accounted, only the insertion losses through the splitters. So estimated is about zero point 0.5, zero point 0.6 dB, which is insignificant, and we can always can compensate that by adjusting input power. The 8-port combiner is a commercial one from Mini Circuits, and is rated to 9,000 watts. So it's definitely will hold all amount of power, and the phase all our signals into the one without significant losses. So that's pretty much I have to show. But I want to conclude that at this point, as right now, our engineering team concluded that based on the preliminary bench test results using 2 pallets, we're confident that we add 6 more pallets and we can generate a right amount of power we needed. That said, it would involve a full amplifier assembly, as well as the telemetry line. So everything should be remotely, everything should be protected. And the biggest concern is it should hold power without thermal faults, which I mean temperature obviously issues for the certain period of time. Ideally, we're looking for 4-minute transmit cycle. So during the transmit 4-minute, the signal packet that we will send out from Earth, because round trip of the signal is about 4.6 minutes at the closest point. Venus is going to be in October. So we would like to use all of these 4 minutes for the transmit. So the next 4 minutes we can look for the signals and receive. It's hard task, by the way. It's extremely hard to achieve, but I'm looking forward with the forced air and a good cooling system and a low ambient temperatures in October, we might accomplish that. So we have something to do and test. At this point, we'll just need to move on with the full completion of the system. Any questions?
Yeah, Alex, the splitter at the front end of the PAs.
Yes.
What did you say that's made out of? What is this? It's an interesting diagram. I'm curious as to know how these work.
Yeah, it's a typical so-called hybrid splitter, 90-degree splitter.
Okay.
We use similar splitter in Eve 25 system.
Okay, so
Um,
they're split like 45 degrees each, right?
no,
So
90 degrees each.
well, of each splitter, but the outcome is that you end up with
Plus and
845.
nine, plus and minus 90 degrees. So or call this a 0 or 180 degrees, either one. It's the same
Okay.
proper state.
Okay.
I'll send you the link in the chat to the web page. If anyone familiar with the VHF, UHF microwave system and been actively operating, and so you might familiar with W6PQL of California, Jim. He makes the skits and also builds the full key amplifiers. So he sells those boards, and I've been using them for at least the last 18 years for sure, and always quality. For 13 centimeters, what is important is insertion losses and also the isolation between each port. And he provides a good quality. These made from not FR4 material, but Rogers material. Is anyone familiar with the microwave design, well aware about what the Rogers material is? It's like a PCB, but more or less lossy on high frequency. So those are what comes to combiner. That is our alternative approach, by the way, Bill, because that wasn't our initial design. Initial design was to strictly use all mini circuits, and mini circuit had available 8-port active phase controlled splitter. That was a killer one because when I mentioned active phase control, I mean you can actually compensate the phase on each output. In this case, what you see on the picture right now, you rely on the proper assembly and fully identical uh, connection. I mean, the solder amount is joined, solder joints, and the piece of wires we use, so on, should be identical. So you don't have extra phase shift. That will translate into the losses, combining losses. So when it's hard, but it's achievable. It's something that you just would need to have instrumentation in front of you to verify that.
Okay.
Unfortunately, the active splitter that I mentioned no longer available and been removed from production in 2025.
Uh,
Since we initially designed the system in 2024, and Miniscircuit actually suggested to us to use their full system, and I'm really excited to use that. And unfortunately, at this moment, they are not available. So I had to go with the option number two to use this. There are no available like all-in-one 8-way splitters on this frequency that you can go on a byte. You can make it your own, but I decided to go with what available. Any questions?
hmm. Yeah. So are there eight individual phases? I mean, in the 360, or are there four?
Now each one is 90 degrees, 90 degrees, 90 degrees, 90 degrees. When it comes to the output combiner, the actual combiner is a 180 degrees combiner. To achieve the right phasing on each one, you just play with the length of the cable. If anyone did any amplifiers with the combining power, I knows exactly what I'm talking about. So length of the output lines would represent, one second, would represent the proper phasing. So you can play with the length and you can precisely calculate and shift the phase. Is I mean, Bill, if you ever build like a Yagi antenna and you did any phasing, like let's
Mm,
see, 4-stack or 2-stack, right? You're talking
sure.
about like a two cables, right? And if you
Mm,
want to shift the phase from one to, let's say, put two antennas at 90 degrees, I want to shift one at 90 degrees and make a circle polarization. I just need to add the quarter wavelength length of the extra piece of cable, right? In this
right.
case, my phase is going to be shifted. So same principle here. Those lines is the microstrip lines, so they are frequency dependent and perfectly calculated. So each one does 90 degrees in this particular case. Output
Okay.
from the output perspective.
Okay.
Any questions?
Oh, Alex, can you go back to the first picture or the second picture? Either one of
Where the
those.
amplifier assemble is?
Yep. Mm-hmm.
You let me know when to stop.
Yep.
This is the first
That's
one.
fine right there. So,
Mhm.
so is the pallet the silver part on top? Is that, or is the whole unit called a pallet?
Oh, palette is something on top, yes. So the bottom portion is the heatsink. And unlike EVE 25, when I actually had to buy the heatsink material myself and tap and drill the holes, it was absolute nightmare for me. And does anyone drill the holes in the heatsink when you have like 18 holes on it to drill and you have to be precisely and you don't have CNC machine and using hand drill? Obviously, that's the hard task. In this case, we decided to use the heat sinks that are already specifically designed. Why I'm saying designed, that means if you put proper fan with the proper CU, which is the cubicle the air, forced air, it will provide the full cooling capabilities for amount of heat and efficiency that pallet has. So top is a pallet that came as a separate part. The black portion is a separate part as a heatsink. And the board attached on the side is the PWM controller with the sensor. Looks like a wire and the lug, but actually is a temperature sensor as a thermistor. So what it does, each of the pallet, a full assembly, as you can see, 250 watts, individually controlled a fan. So regardless of the temperature, each one has own way to control base of the heating. I would expect they're all going to be heated in the same way, but
Is the fan inside of that black box area, or does it attach
no.
to the outside?
Let me.
Yeah, I didn't see an end shot of any of those
Yeah,
anywhere.
unfortunately, I don't know why I don't have that picture here, but the fan it's right below those boards and is attached. If I go here, is attached on the front side with the not the and the connect output connector is, but when the input connector is and kind of two standoffs there. This is the where the fan attached to. So
So the
it's
fan
actually
attaches to the left
side.
side in
So
the image here, to the
correct.
out, to the outside of this. What are the
Yes.
dimensions approximately of this box?
Pretty small, very small. I'd say probably. You know what? I don't want to guess. I'm gonna give you right exactly to you right now, and I open that data sheet right here, and I'll show you that screen with all you guys because you can see everything. All right. So I'm gonna unshare this, and I'm gonna share this screen. So let me know when you see it. So, okay, you see that?
Nope, nothing yet.
I hope I'm sharing. Oh, 1 second. My bad. Sorry, I put it there. Um, supposed to
Ah,
be okay now, right?
oh, and there's the fan.
Yes. So this is how it looks assembled. And as you can see, this is the 250 watts, and it's kind of funny when I look at the first time when you look at say a solid state, we call this SSPA solid state amplifier, 250 watts, right? It's kind of you see right away. Then the high output power. Oh, sorry. I don't know what happened. How output power 300 watts. So they mentioned 300 watts and 250 watts on the same statement. And if you go down, scroll down, you can also see from 1 watt to 300 watts. But they advertise this as 250 watts, and the part number also said 250 plus. So when I tested pallets on our frequency, it was generating roughly about 225 watts, 230 watts on the second one. And when you go on the 2.4 gigahertz, it actually generates solid 300 watts. So I'd say it's 300 watts, no problem. And efficiency 60%, I mean, the 40% of that efficiency would be just a heat generation. 42 dB, it's very good. And this is what internally, unlike any ordinary amplifiers that we normally use for amateur radio, and this amplifier is commercial grade. What is a commercial grade? That means it has an industry standard telemetry line we call I2C, and I2C is anyone familiar, it's just two wires, simply two wires and a ground reference. So, and that means everything, every single virtual signal, and that's whole table of them um, over, right here. So you can get through the I2C temperature, current, forward power, reverse power, alarms, state of health, and things like that. It's unbelievable how they approached, and then I wonder why it costs this amount of money. This is dimensions. Sorry, Roger took me quite a. It's 6.7 inches long and about 2.2 inches across. And as you can see, it's less than an inch thick.
Well, including the fan, how about the heat sink? How tall is the heat sink?
Um, Heatsink is right here. So with the
Uh,
heatsink altogether,
three and
3.6.
three quarter.
Yes. So my idea, because we know we have a limited space in the hub.
Mm-hmm.
Um, Unlike EVE 25, when you have all this brick assembly with the power supplies, um, I see that I would not put power supplies this time inside. I don't want to have 8 power supplies inside in the same usable space where the amplifier should be. Amplifier should be as close as possible to the feed point. Power supplies can be outsourced outside or spread it inside along both walls of the hub, internal walls of the hub, 4 on each side. We'll think about this later. So if you take this 2 amplifiers assembly with the sizes, as you can see, 3 inches by 3 1/4, and stuck them together to form at one pallet of 2, and then another 2 on the sides and another 2 on the bottom. So you made a cube of 8 pallets. 2 on top, 2 on the bottom, and 2 on each side. That is in the vision how we're going to mount the amplifiers inside the hub. If I remember, the diameter of the entrance of the hub is 17 inches. Am I right?
Yeah, that sounds right.
So that would be our footprint. And compared to the size of the 25 that barely fits into, this is going to be a lot smaller. So I think we're doing good, but someone has to take a lead on getting this footprint accommodated inside, probably the same way we did for Eve-25 using your approach of 2 plates.
Okay, so yeah, actually, if we're going to put the power supplies on the outside, actually put them on top of the probably on top of the hub.
Yeah.
What kind of cables, what gauge cables do you think you're going to need to run between the power supplies and the
Um,
amps?
yeah, and that's exactly why I want to open this picture here. So first of all, I want to give approximate dimensions of the power supply. So keep in mind that's not inches, that's centimeters and millimeters in this case. So it's 160 millimeters, the length of the actually 225. I'm sorry, 225, and 124 millimeters across. The current, each pallet rated about 16 amps. I bump a little bit more power, I'm sorry, voltage. So from 32 we can go up to 36. That's per data sheet of maximum. But stick about 23 and 34 volts. That gives us a less current than 16, and so therefore we can have more less, I guess, heating concerns. So this is the size of the power supply. Gauge, I'd say it's probably between 12 or 14 AVG. That's what I go with based on the current cross section of the wire
So
stranded.
the equivalent to house wiring.
Pretty much, yes, because we're not gonna feed amplifiers from one power supply. Each power supply dedicated for each pallet. The reason
Yeah.
is behind is, first of all, it's a lot cheaper to use separate power supplies than one high power. Also, from failure perspective, if one power supply fails, it can take down multiply of a pallet. In this case, if one power supply or one pallet is out, you still have the rest pallets combining power still. You're not losing the entire system just because of failure of one power supply or amplifier.
What's the input to these power supplies? 120 or 240?
Good question. You know why? I was very surprised. I did not actually, when I was building, oh, I'm sorry, ordering this part, I didn't look on that important part. I kind of forgot about it, to be to be honest. When the power supply arrived, and I look at that switch on the side, it was set to 220. I'm like, oh my God, did I buy wrong power supplies? And then another thought I had, well, why they ship it to 20 then, right? I'm United States. So apparently this power supply has a switch 115 to 220. And when I saw that, it struck me so nice because we do have 220 on the hub. So instead running all these power supplies, and I calculated the amount of power we needed. It's I think it's close to 9,000 watts, something like that. uh, um, Instead running from 110 and overloading 110 line, we can take 4 power supplies on 220 line and another 4 power supply on another 220 line that we have available on the hub. And 110 would be considered for house power supply, 12 volts, and all this low voltage circuit supply.
So Alex, so the system is tolerant in the combiner if we lose one power supply or one pallet, and
Correct. And
it
I
doesn't
did not.
overload anything or change the loading or anything. That
No,
seems almost magical.
well, it's nothing magical. It's all about impedance, Bill.
Well,
You make
sure.
sure you have a proper impedance, right?
Oh,
So,
I got radio
can I?
stations that do this, but I wasn't so sure we could do it. So that's cool.
So, I can go back right here. I forgot to take a picture. The first thing I did when I received this pallet, I'm looking for these. Okay, here. When I received, I opened the cover to see what is inside because I've designed and built my own amplifiers a lot for different bands. In this particular amplifier, the designers they thought about everything as possible. So this circle with the error and the load, you know what to represent, correct? On the drawing,
I don't.
18.
I'm
Okay.
software. So tell me.
Okay, it's called isolator. Also, people call circulator sometimes, but this particular one is isolated. What is supposed to, in case if I'm gonna take, let's say it's running full power, right, and something happens to the load, so I can take the cable and disconnect from the amplifier, right? A neural amplifier, that might gonna cause damage if you don't have any protections, right? This particular case, what happens, because you have a high reflecting power coming back, this power does not go back to the amplifier, a final transistor. It gets circled back to the load. So all the same power that been produced by the MOSFET, but the final transistor, gets circled back to the load. So no matter what happens with the output, the power amplifier stays terminated to 50 ohm because of that. This is for protection purposes. So now
Hmm.
imagine that small size of a pallet, it has a good chunk of its size dedicated to that circulator because it should hold power, right, to 20 watts, at least 300 watts, and also load that rated to 300 watts as well. It's like a terminator built in. So the amplifier stays terminated, right? And when that happens, event, it doesn't mean the amplifier is going to be running and putting this power. It's to protection purposes. But at the same time, it triggers the alarm. When it triggers alarm, the amplifier gets shut off. So it's a sequence of events. Something happens, the power doesn't kill the MOSFET final. It goes circle to the terminator, and the same millisecond, the amplifier gets shuts off, gets out of the line, and then the other amplifier continue to provide the whatever remaining power is. So the system will be producing power still.
Question.
Okay.
That's very good.
Go ahead. Remind me about how much do one of these pallet slash heatsink and fan, just one of them cost?
How much? $800.
Okay. That's actually for my own interest.
Yeah, I mean, if 250 watts, it's okay power for EME. Especially for our size of a dish, is definitely going to be pretty good addition. Two of those pallets will give us pretty good significant amount of power that can easy for SSB and CW. So actually 250 watts also give us ability CW and SSB because of a gain antenna will increase over the 23 centimeters. So yeah, $800 is doable for amateur radio to afford to buy it because as higher frequency you go, obviously, I recently purchased 10 gigahertz amplifier with 30 watts only, 30 watts, 10 gigahertz. How much I think I paid for it?
I don't even want to guess.
2,500 watts. $2,500. I'm sorry. So that's the cost of operating 3 stations in a year. But we're passionate engineers, so don't tell to my wife.
Well, it costs a lot because of the thousands of people you can talk to on that frequency, right?
Um, to to kind of conclude your question, Roger, $800 is not just because of the parts. Probably if you build yourself, it will cost you less than $100. The most expensive part going to be the offset itself, which is roughly about $30 you can buy, and the rest is going to be just a circuit isolator. But it's just because the approach, the commercial approach. First of all, it's a commercial amplifier. It's not for amateur radio. It's ISM band, which is what we call 4G, and obviously it's rated for a cellular system, cellular stations. So that's why the design itself, the ingenuity behind, as you can see, so many control and monitoring circuitry there. So you can squeeze any parameters and make it fully remote, which is perfect benefit for us as well. I had to design the circuit based on TNZ. If anyone aware what the TNZ is, it's similar to Arduino. I think Roger, you're a software guy, you're well familiar with what the Arduino is.
Hmm.
TNZ, it's a lot more powerful for me. It has pretty good RM, the processor and the capability. But in this case, it has tons of the input and output that I needed. So one simple board accommodates 8 pallets. Since it's I2C, it's a parallel bus. That means you can connect as many loads as possible on that. So I'm using just simple buffer 1 to 8, and each amplifier gets own I2C bus connection. And all the telemetry from each pallet would be displayed on the software. So not only display it, you can have any protection you needed. This is next level from EVE 25, where we use, as you know, the available from amateur radio colleagues system. Um, in this particular case, the DSES will design completely on circuitry for monitoring control. Any other
So,
questions, guys? I don't want to take too much time.
oh
I,
no, you're the only topic at this
I,
point. So,
I
Oh,
have a
okay.
quick
I'm
question.
sorry. Yes,
I have a
Edwin.
quick question. Alex, this is Adrian. I noticed on the
Adrian,
very
go ahead.
first, yeah, I noticed on the very first page of the spec sheet for the amplifiers, it says that they're suitable for CW and pulse. Are these Class C amplifiers?
Um, well, when I talk, well, depends what modulation we're gonna use, right? So, in this case, we're not using CW modulation for the case for the Eve 26. We're not using Q65. If I'm not mistaken, now let Rick to talk about that topic. What kind of modulation they decided to use? I think it's ORI Institute, Open Research Institute,
Yeah,
working
I'm
on some
familiar with her.
special,
Yeah, I'm familiar with
yeah,
that.
the special protocol, and I don't know what to modulation. When I presented options to mini circuit designers, and we're talking dated back to 2024, where we start initially having talks about this system, and they said it's going to be no problem. So once again, the performance that listed here, it's specifically to the part of industry this amplifier design. It doesn't mean those are limitations. So the amplifier capable to, let's say, I've been using and playing here on my bench of different modulations on amateur radio spectrum modulation. I had no problem. So I don't know what else capability or what kind of modulation we're gonna go with, but this is the best option we have. There would be no additional options. And to finalize mini circuit, I thought the mini circuit will continue to support us, but unfortunately cut all ties with us. The reason was that when tab has been introduced, mini circuit went through a lot of headache just because of that, because majority of the parts and components and assembly done not in United States, outside of United States, and they're very heavily dependent on that. So they cut the production of many systems and included these amplifiers. They're selling out the stock right now. Basically, all of them obsolete at this point, and they are no longer looking to produce more of those. That's why those active combiners are being removed from the stock, and these amplifiers, whatever left over, and they're done with it. There were no more support. So I wish I could contact them, but they decided not to continue any conversation with the Space Exploration Society at this point.
So that's the reason for my question. If these aren't linear, if they're just Class C, then that would limit like OFM type modulation or something like that, where you're doing some kind of carrier phase or something along those lines. So that's why I was wondering. Strict
Yeah, well,
Class
it's
C and
it's
not linear.
yeah, it's a reasonable question. So that's what the bench test was. Part of we had few concerns, and that was one of them. Also, not linearity, but phasing. You know how we can combine all of that. Miniscircuit once again provided the application note. I don't have it right in front of me as a part of our package. The application note was actually described how to build 8 pallet system. I don't know who requested that initially, but they had that application note where they suggested to use all of those components they suggested and basically replicating the system we wanted. We were excited about that because the mini circuit would guarantee the performance we needed. We did mention digital nodes and especially Q65 in that moment, where we thought it's going to be the solution for us, but I don't think the Q65 now is still current for us, so we're not going to go that path. But when I did bench tests, I tried to prove multiple points. And there are some deficiencies, but they're insignificant when it comes to other goals. And I tried different modulations type, once again, with the capabilities and limitation I have using the ICOM 705 and the transmitter and computer. But I didn't see any major upsets. Perhaps there was a reduction of the power and efficiency, but that wasn't something that caught my eye right away. So once again, I would like to know what is our approach from the modulation, what we decided on. That's not my call. And I'd like to hear from Rick what we add when it comes to modulation and a format of the message we're planning to send.
Can I
Well, yeah.
let me ask one quick question before we get to that. You say they cut ties with us. Why would they do that? They're located in New York. Their headquarters is in Brooklyn. What is the reason they cut ties with us?
Because they don't want to they no longer want to talk about the parts that are obsolete. So
Oh,
this amplifier they're still selling, but they don't have support of this amplifier because it's obsolete and they're selling out the stock. Um, if you go on the website and choose one of the part numbers, right? The first message you're gonna get that this part no longer supported per this application note. Read it, blah blah blah. You okay with the statement? Click OK, and then you go and you want to purchase the amplifier. There are no other alternative amplifier. Normally, the message would tell you this product is no longer supported. There's a new product, and in suggesting you to purchase the product. When it comes to this amplifier, there are no new projects, new amplifiers available for this
okay,
recognition.
okay. We'll go back to Rick. I'm sorry.
Yeah,
Thank you.
and by the way, Bill, I sent about 24 emails to them, and they made numerous calls, and none of them ever came to me. And guess
Oh,
I wasn't stupid. I was sent emails to different emails, not
yeah.
just a single one. None of them will ever replied. And I tried to call their sales and as well as the technical application. Nobody want to return neither my calls back, neither answer emails. So sorry, I
Wow.
don't consider this. Yeah, exactly. I would have considered mini circuit. And I've been dealing with a mini circuit for a long, long time, from the day one of my career back in 2005
Yeah.
when I've been
Alex, are
building
you
it.
going to buy a spare?
Uh, yes, we have no choice because
Yeah.
if we want to build the
Right.
amplifiers, we have to have a spare, and they are available. By the way, it's not just they have like one or three. They have plenty of amplifiers available. I guess we're only one vendor who buys them right now, I believe.
Okay. Good.
Yes. By the way, there was a question from Sarah.
Where? In
It
chat.
it, it was in a text
Oh,
Was it in
what
chat?
was the question?
chat. I'm sorry, chat.
I
Hi, this
forgot.
is Sarah. Yeah, so I'm new here. I was just curious by listening to the conversation. It sparked my interest. I'm curious what type of modulations are commonly used in, radio astronomy and ham radio applications. And also, what is the Class C categorization?
Well, all good
You want to
questions.
answer that, Alex?
No, Adrian, go ahead. I just need to have a glass of water. I'm sorry, I'm just
Oh,
dry
okay.
out and
Well,
have a
okay.
massive headache here. Go ahead.
Okay. I can briefly describe it. So when you have an amplifier, there's different ways that you can amplify the signal. Okay, and the different ways you can amplify the signal will introduce certain distortions to it. And for example, if you're doing something that's going to have a linear output, something like either AM, like amplitude modulation, that amplifier has to amplify each and every one of those levels linearly. Okay, so those are usually categorized by different letters, and they're called either Class A or Class AB. And so those different classifications usually typify linear amplifiers. So it means that the signal that goes in, if it changes intensity, those intensities are amplified linearly. When you have a modulation like frequency modulation, where you don't have an intensity, the signal is always of one intensity. It just changes frequency. You don't need to amplify those signals linearly. It could just be full blast, all the signal that goes out at one out. Okay, because the only change is frequency. If you're using FM, you can use this Class C. Class C does not amplify linearly. Basically, the signal that gets amplified to the maximum amount, and then it goes out the output of the amplifier. So a Class C amplifier is not. So if you're using something like AM or single sideband, you can't really use Class C. And then also for the digital modes where you change phase of the signal and you have different degrees of phase on the signal, you need linear amplification. Obviously, that phase has to be linearly amplified. So again, what the uh, what the what the spec sheet said was it's good for CW, which is continuous wave. That's like telegraphy, but it's either on or off. That means the signal is either full power or gone, off, and or pulse. You just pulse, and that pulse is the maximum power, and it doesn't have any linearity associated whatsoever. So then Class C is the type of amplifier. Again, if you want to use something like amplitude modulation, single sideband, you need linear amplification, and those amplifiers have either Class A or Class AB. There's even a fourth class. It's called, I'm not even going to get into that. But these are the ones that apply. Class C then is a nonlinear amplifier that's either power or whatever. I don't know if that helps or not. It's not the best way I can describe it.
No, thank you so much. I never heard of the different kind of categorization, but they definitely make sense. So thank you so much for the crash course.
Oh, you're welcome. Just look at any ARRL handbook from any year up to whenever. It'll go into full depth describing. You have to bias essentially the amplifier different ways as to how it amplifies, and that's kind of the main difference. So anyway, go check it out somewhere. It's a good educational part of amplifiers.
Yeah, Adrian, thank you very much. That was very helpful, informative. And
You're most welcome.
yeah, what Class C, I did verify performance of the amplifier using FM modulation,
Yeah,
which
that
is
works.
yeah, and I was not, and I did multiple steps. I mean, I've done it numerous kind of validation tests. I used to be a validation engineer at some point, specializing for 30 megahertz amplifier systems to comply with the FCC and the special mill standard. So, and that's when I've learned a lot about that. And using linear, nonlinear, and all the first order, third order harmonics and everything else. But here I just blindly, okay, what I have with me, can I test and see if it works? Now, once again, I could not get more than 220 watts no matter what I was doing. At some point, I was able to get 230. I found out at 15 dBm. I have, I think one of the pictures and I show, if you guys notice, there was a variable attenuator on input. So I first to say, well, the what the let's say what is it on here? So input power, as you can see, set 12.5 typical and 15 dBm maximum. So I really don't want it to exceed 15 dBm. Now the transfer, CUNY transfer, was generating about 2.5 watts. Obviously, that's not 15 dBm, right? That's over 40 dBm. So I'm sorry, 40 dBm, 34, 33 dBm. So it's kind of more power than I need. So I have to use a variable. What was the point of that? Not just to unlimited power. Find out the saturation point. So at which my amplifier is saturating, and I defined that was the input power. It turns out about at plus 16 dBm, probably because of the extra losses I had there, I reached a saturation at which my current doesn't increase. I'm sorry, my output doesn't increase, and input power does not affect the output. So that is saturation point. Smoke, okay. At this point, on this particular frequency, 2304, I can only max out 230 watts on one, and another one was 225. So pretty much close to each other. Then I was playing with different modulations, CW, FM, and DV mode. If anyone familiar with the 705, it has DV mode as well. Surprisingly, I didn't see much difference on the output signal, and I'm using mini circuit power sensor that rated to 6 gigahertz. And you can switch. There's RMS on peak power, and I didn't notice any significant degradation of performance from amplifier. I would suspect that the amplifier is capable of more, but how designed internally? Go gas. I mean, you're not gonna find any circuit for that. And my attempt to squeeze mini circuit to provide some technical guidelines were unsuccessful. I think they're not willing to help on that. The other thing you can do is reverse engineering, but that would require tier amplifier apart, which I didn't want to do that. It's $800 piece. So I end up just assuming that we're okay at this point. But once again, the question remains open. What type of modulation we're planning to use for E25, 26?
Well, Michelle at Ori has her meeting tomorrow. I'll ask. I usually
Yes.
attend some of those. I'll ask her and see what the actual modulation that they come up with. I don't know. Rick saying he came in. Maybe he knows. I think he's kind of he's also involved.
Is
So
Rick? Oh, Rick is here.
yeah, he
Well,
can maybe answer that.
let ask Rick because I'm interested in that as well.
Oh,
Okay,
what is
can I
the
ask one or two more
question?
questions?
Yeah, Rick. Question is, what kind of modulation are we planning to use for E25?
Oh,
E26. I'm sorry.
I, first of all, those amplifiers are almost certainly Class C, which limits the modulation types that are useful. The modulation type that's being proposed is something I'd never heard of before. It's a Zadoff Chew constant amplitude zero autocorrelation modulation, which is excellent for Class C amplifier use. So I don't see any problem there.
Okay. Well, perfect. Because I thought we initially discussed about that, and otherwise we would have caught any issues at the beginning. But yeah, and as I said, I tested FM for about maximum about 3 minutes until the thermal fault kicked on. Because keep in mind, my ambient temperature in air is only 100 degrees, so
Yeah.
it's not enough cooling capabilities to cool down. But it would probably last more than 3 minutes on transmit if you have a sufficient airflow. And those fans, by the way, are server fans. And I already shared that video. It's extremely noisy. I couldn't stand next to two fans. I don't know what's going to be with the 8 fans there. So it's going to be enormous amount of noise generated by those fans. And I think one of the modifications when you apply to hub, Roger, is we can't use the plate cover on the hub because we have to force air through that opening into those fans and blow that hot air through the power combiner is going to be located between the amplifier output and the feed towards the other opening on the other side. Obviously, that's not waterproof at all, but that's only constraint we would have. There would be no any other options drilling the holes or anything like that. The plate shall be taken off completely.
Can those
Rick,
fans be either pull or push by any chance?
I'm sorry, can you repeat that?
Are those fans either pull or push, or are they only push?
No, they're not pull or push. You need to flip them if you need to.
Well, and that's what I'm wondering, because if I remember your picture here, the end connector is on the opposite side of the where the fan is.
Yeah.
And so given that orientation, what we're going to be doing is we're going to be taking hot air and pushing it down. But if it can be changed to a pull, where we can, we can get a natural, we can work with the natural draft of hot air rising.
Um, yeah, pull and push. Yeah, I am trying to. So the I well the mini circuit application note, I believe it's open here, if I'm not mistaken. So this one, right? Yes. So this is application note AN60-110, specifically for a heatsink mount instruction. So they instruct you how you need to mount the fan, heatsink, and do you need to pull and push. And we'll scroll down to here. So right there. By the way, yeah, worth to mention, the fan itself consumes 2.3 amps, and I thought that was a mistake. But when I turned the fan on, yes, indeed, one fan draw 2.3 amps. Unbelievable. So I have to reconsider what the 12-volt power supply should be now, because multiplying by that amount of signal fan by 8, that at least like a 25, 30 amp 12 volts just to feed those fans. Now, fans are PWM controlled, meaning it depended on the temperature. It has 4 different speed grades. So based on the ambient temperature and the sensor reporting, it will provide sufficient amount RPM based on that. Assuming it's all hot, and that's why I like this, because it's fully controlled. I don't need to do anything with it at all. We're only going to monitor the temperature for each pallet individually remotely, so we know what's the state of the temperature
Yeah,
inside.
scroll up just a little bit. I think the answer's there. Airflow is going into the heat sink. Okay, so we're
Right.
pushing air.
Yes,
Um,
and that's how it works right now. So those fans, the fan side, is oriented towards the opening of front side of the front side. I mean, when we install the system, not the feet side. If that makes sense.
okay. Switching gears a little bit, Edmund actually touched on a question I have. The I squared C, are there multiple addresses used within this device, or is it just a single address where all the information is available from a single I squared C address?
Um, well, obviously, I'm using numerous. Each amplifier has on, and that's also programmable. So as you can see here, 3 address beat: A2, A1, A0. Depends on the jumper you're gonna set. That will define what your what address is gonna be. So I use different. Also, I use ADC, which is analog digital
Oh
converters.
yeah, we're gonna exhaust the addresses with those 3 bits. Okay, but they're all
Yeah,
there.
but there also can be on the same address. Depends on the purpose. I mean, amplifier. Yeah, if you want to control individually, then yeah, obviously each one needs to have a dedicated. But what I'm doing, I'm taking the I square C buzz from each amplifier that goes to the buffer. I believe it's called TCA 90, that TCA 9548. Um, if anyone familiar with that. So it's a eight channel I square C switch. When I well basically switch, it is switch. It's so fast. Let me see what's the speed. I think it's in milliseconds or something like that. Basically, in case it's semi real time, I'd say. Well, if let's say your eye can see the difference in 10 milliseconds, that's how the TNZ will ask each pallet at that rate. So within a second, it will be probably third round. So all these numbers will be changing with that refresh rate. So I'm using this basically switch that connects to the each amplifier, and the input connects to the TNZ. So each of the amplifier address defined on the TCA board itself. Make
Okay,
sense?
so you're actually switching, you're creating multiple I squared C buses from that
Eight.
device.
It's 8 channels,
Yeah.
so 8 of them.
Instead of addressing them uniquely.
Yeah. So yeah, I don't see where's that, but actually it's not something that in theory I already built circuit and works flawlessly. And I have already everything assembled to I squared C. It's something that unique for this purpose, something I've never done before. Never needed. I mean, never needed that. I dealt with I squared C a lot, but not this particular case. Have a 8 palette. And also, I wrote the Python script that has 8 channels, and individually we can see that each power. Because if the amplifier itself provides analog outputs, such like for forward and reflected power, as well as the temperature and the current, those goes to ADC. And what we do, we convert analog into digital and put them back to the I2C. So convert analog outputs back to the digital for convenience. And I can calibrate each palette individually based on actual power it produces. That's what I was doing here on the bench test. So I can correlate 220 watts into a certain amount of power, apply the offset, and show a linear power on my screen individually, and then combine the power, because I don't think we'll be able to measure a real-time power on the output. I can see what kind of directional coupler, unless any of you guys can donate very nice directional coupler. I simply can't find on the market. There don't exist such a power that hold at least 2,000 watts, so we can have real-time forward reflected power measurements. So I rely only on the assumption, counting each power individually and subtract the insertion loss from the coupler, from the combiner. And speaking
Okay,
combiner,
going back
this
to
is the
I squared.
combiner. Okay,
Yeah,
Georgia, go ahead.
going
Sorry.
back to I squared C. I don't want to discuss it right now, but I guess I'm I'm wondering about why we're switching the I squared C bus instead of just using the 8 unique addresses that are available for the 8 different devices. But that's a discussion for some other time. Another question I have is the feed. Um,
Yeah.
so are we getting a new feed, or can the ham designs, RFM designs, does it meet the requirements? Can it handle 1500 watts?
Answering your second question regarding the ham design, absolutely not. It will never
Okay.
it will never, forget about that. So that toy, comparable what we have. I have a couple thoughts and I can share it right now. First of all, before I go too far on the feed, and I think that's probably kind of a moving from the beginning of design through the pallets all the way to the antenna itself. This is the combiner. So I wanna give you the sense of how combiner looks. There's only one combiner available on the market, and is, as you can see, rated to 9.6 kilowatts. It's it's a heavy one, and it has the 716 type of a connector, D connector, 716. So it's the same size of connector we currently have on Eve 25. Um, so and then as you notice, each of the pallet has N-type connector. So we would have a cable connection between each pallet to this combiner, preferably a low loss cable at short distance. But one thing I need to mention, that this combiner, because of only available, it has 0 to 18-degree combining. So we're splitting 90 degrees and we have to combine in 180. Normally, I would not go that route because I would like to have fully phased system. In our case, because that active splitter that we could adjust phase individually per each port does no longer exist. Um, Even I tried to find the used one, I could not find any. I had no other option to use 90 degrees and then phase it to 180. How it's done? I already mentioned that when Bill asked. It's about the length of the cable. Because of the wavelength of 13 centimeters, You need precisely cut the cables, so it would be 4 cables of one length and another 4 in different length. In this case, we will be able to match the proper phasing. Now I rely on experience and the ability to do that. Dave Wilson, Alpha Alpha Zero Radio Sierra, who will be working on the final assembly, I will support as best as I can. I've done this in the past successfully. It's just a matter of doing with 1 or 2 pallets first, see if it works, and just basically replicate for the rest. So this is combiner. What I like of this is also unbalanced. It's 0.1 dB insertion loss. And I'm sorry, the well, insertion loss and as well as a 1 degree unbalance between the phasing, which is very, very good for us. So that's the option. Now from feed. Um, so my plan is to build feed specifically using the OM6 alpha design. It's the round circular feed. Yeah, I believe it's the one of the feeds we have on site, but it's going to be with the septum inside, and a septum would be a lot thicker to hold to have a good precise isolation. What I'm willing is to I do have what I call the dimensions scale down. We would need to find, if you guys know, Roger, you and Bill, um, anyone can do light laser cutting. Is it possible?
I don't have any access to that. Bill, do you?
Unless we've got one of the maker spaces has it. Do we know?
So what needs to happen is we need to cut using laser cutter, cut the aluminum sheet, the precise septum size. It's like it's like a letter type of thing. It's exactly the same what we have in our feeds, but it's going to be a lot thicker with the threaded holes in the middle, so we can
Ah,
use this to mount.
Um,
I'll
we should
send the design to you guys so you can take a look.
we should probably
okay.
talk to Kilroy's workshop. They're probably the best equipped makerspace here in
Yeah,
town.
to assemble it. Now, other thing I forgot to mention. Now, for the combiner, do you see something in the middle? What it
No,
looks like?
it's a plate.
No, it's actually a waveguide.
Okay.
It's a waveguide flange.
Oh, okay, that's what that is. All right. All
Yes.
right.
So, because of amount of power that is rated for, and for the cellular system, in this case ISM band, 4G, name it, whatever, um, they use waveguide output. So it's a standard waveguide flange. Now, we're not looking to have a waveguide transition to our feed, and our feed is going to have a waveguide. So we would need to have a waveguide adapter that's going to go from that flange. I don't remember which one they have mentioned. What's here? WR340. So we need to go from W340 to 716 DIN connector in order to transition back to the feed. That would cause some losses. That's why we need to have high power output. It's not just because we want to violate FCC and running 2000 watts. No, it's just to overcome those losses between the output and the feed input. So make sure we're
A-
putting into the feed 1500 watts.
Alex, could you repeat that? You want a WR340 to what?
716.
Oh, to the 716ths. Okay.
Correct.
Sorry, I
So,
didn't. I was.
yeah, we can. Those are exist. It's not something we need to build or manufacture. Those are exist. We just need to buy it and install it. But I
Is,
don't anticipate having the feed with the waveguide.
Yeah.
okay, so
Oh,
there's no way to actually marry this to the feed
Well,
itself.
good question. I haven't done this in my professional career, building the feed, the septum feed with the waveguide flange. It is possible though, but I'm afraid to say it, but I have to say it. I have to be simulated. So that means we need to create a model. If anyone here on the call aware or familiar with the HFSS or CST Microwave Studio, anything that simulates in a microwave, we can actually simulate is this transition possible. Therefore, if we're gonna make that, all we need to do attach the 90-degree waveguide piece and mount the combiner on that piece, and it's gonna be all intact to the feed. I'm afraid, Roger, that we're running out of time and we're not going to be able to do this, so we have to have option B.
Okay, I'm just, again, I'm software, but I was just thinking if it's plumbing here, it'd probably be best to keep it as plumbing.
Yeah, unless anyone else, Adrian and anyone, would suggest any other combiners, but unfortunately I could not find any. And that what comes to being on 13-centimeter band and running these powers. It's really hard to find sufficient parts, and they need to go on the commercial market to do that. So, any other options that we can substitute this combiner to other possible combiners? This is the most expensive part, by the way. It costs $2,500, just this piece itself. So if we find something other option or any suggestion from you guys, go for. It's a perfect time to do it right now. Otherwise, we're running out of time and we need to commit ourselves to what we have and available.
Yep,
I did a lot of research. I could not find any. I don't know, maybe I was not looking in proper places, but
okay. I just found a WR340 to well, this is to N, not to
no, we need
7/16.
7/16.
So yeah, okay. I'm just wondering. I think I've gotten all my questions answered, so I'll shut up and let other people answer or ask questions.
No, yeah, no worries.
By the way, Megan mentioned that the Eads High School may have a laser cutter.
Perfect. That's good. What I'm gonna do, I'm gonna prepare a package of the drawing package, what we need to cut, and then perhaps we can manufacture a few components, and so we can build a prototype of a feed that matches our FD ratio of our dish. So so we get squeeze the maximum efficiency as possible. There are some remaining questions still open, and but they are not stopping us to proceed. It's something I don't want to make a kind of motion and so we can proceed just because of that. Without building amplifier, we're not going to be able to drive anything and put anything into the feed. Without proper understanding what kind of modulation we're going to have, we can run an amplifier. So at this point, all these stars lining up in a perfect combination, the only biggest concern is the time, and we're running out of time. 3 months is nothing for this kind of effort. So at this point, we just need to commit, move on, finalize the assembly, make sure we can generate the amount of power we needed. Next step, in parallel, perhaps we can work on the feed assembly and as well as the rest of the logistics and communication. I'll continue finalizing the I2C control system. And meantime, also we have 23-centimeter band system available too as our backup, I believe. So EVE25 hopefully will be used again successfully in this case. I rebuilt the control circuit. No more issues for the fans. No more issues with the LNAs, thanks to Piotr, Alpha Golf 6 Echo Echo, that who designed this beautiful two preamps for us. And also, I rebuilt a new driver, so we have a better capability of controlling output power. So, any other questions?
Are you going to use the B210s to drive it?
That's ideally yes, Paul, and that's our desired way. But as far as right now, I had well, I don't have them in possession, so I cannot verify are if they able if well 210, let's say 210, right? I believe we have two of them. Is 210 capable to generate 15 dBm or plus, or do we need to have a buffer amplifier between them with a filter? So it's still questionable, but I believe that was our intention to use B210. However, Eve 25 system, what I initially designed back in 2024, if you recall correctly, it has two bands. I incorporated 23 and 13 centimeters inside of 25. So it's a matter you controlling and switching between 23 and 13. But you cannot operate those two bands at the same time because both amplifiers, there's absolutely no way they can feed inside. So the final needs to be replaced. So if we don't have 220, 210, and it's going to be second option, it's still doable. We're going to use transmitter. Least desired way because we're going to compromise our noise figure, we compromise our dynamic range, which is very essential. All comes to 13. If you're not aware, people here on call, 13 centimeters, even though on 10 again higher, it's harder to get Vitus bonds than get on 23 centimeters. So that makes sense. But it's still doable. So we'll make sure. I want to ask Rick about B210. Is our initial plan is still to use B210 as a signal generator and our main receiver?
I would like to say yes, but I don't want to move it out of the control room. So we'll have to talk about that.
Let's discuss it tomorrow night.
Yeah, let's discuss that because first of all, we need to prove the concept. It's the feeds, and do we need any additions to that?
Yes.
As option B, as I mentioned, we do have 13 centimeters transmitter built in already and can be used. But I rather not to use it with known compromises and use B210 right at the feed point. Anyways, we'll talk about that tomorrow then during our board meeting. Any other questions?
Yeah, I had one for Rick. Rick, I'm a little slow on the uptake. Can you name the modulation scheme again?
Could I?
It was
The modulation scheme, as far as I know at the moment, is ZOFF, Z Alpha Delta OFF hyphen capital CHU. That's two people, ZOFF Chu,
uh-huh.
and it's a constant amplitude zero autocorrelation modulation scheme.
Constant modulation,
Constant amplitude,
amplitude, autocorrelation,
zero autocorrelation.
zero autocorrelation. Okay. That's a mouthful.
Yes, it is. And I'm not 100% sure we're still on that wavelength. So tomorrow morning, I'll bring it up again at the ORI meeting.
That's good. Thank you very much, guys. Thank you, Alex, for putting that together for us. And we
Very
can
good.
bring that up a little bit more discussion tomorrow at the board meeting. Just a reminder to everyone, on the 24th of August, we are going to have Scott McIntosh giving us a presentation at 6:30 that day on, and it'll be all about the sun. So,
Okay. Paul, don't jump too quick. One of the things that one of the things I'd like to see us do in these meetings is maybe at the end we could recap the chat window. You can copy out the chat window with the little three dots at the top where you can save the chat. But like Megan was asking, or no, it was Sarah was asking about the the modulation, and Ted put up a couple of good references for the modulation and some other things there that are lookups in the chat window. So don't forget to look at that or copy it out.
It will be in the report that I'll be providing.
Yep.
I also want to mention I'm coming to Haswell at September 10th, 11th, that weekend. And my primarily goal going to be, I will ship ahead of my trip the remaining modules for Eve 25 that I had here to rework. They're all completed, so I'm gonna ship that. I'm not gonna be able to take that wall with me. It's a heavyweight, first of all, and bulky. I'd rather ship it. And I'll be arriving and working on finalizing Eve 25 with all these new boxes and do bench test for that. That's my prime reason, but I'll open to do anything it's possible, and if it's Rick gonna be there or anyone at that time, I also consider that our system going to be completed at some extent by Dave, so we'll be able to test that too. And also, I would really love to have feed completed by that time as well, so we can test that feed perhaps using for the DSN Pro perception on 2.2 gigahertz.
What were those dates again?
September 10th and September 11th, 9/11.
Okay.
Whatever. Yeah, I'm coming on as always on Friday, full Friday, Saturday, and Sunday. I'm flying 10 p.m. So it's gonna be a long trip.
I'm doing the
Thanks.
chauffeur. I'm driving him down, so you can send it to me if you like.
I'll cook you breakfast for that, Paul. Don't worry.
I appreciate that. That's really good.
All right. So anyone want to come enjoy and learn about what we're doing and participate and help us? Feel free to come.
So the 10th is Thursday. So you're flying in Thursday, is that it?
Then I believe 11th, then Friday. Oh, yeah, Friday, 12th, Saturday, correct? And 13th, Sunday.
Okay, so the 11th through the 13th is when you're going to be there.
Yes, sorry, I mentioned 10, but whatever weekend will fall into 9 and 11. That's
Okay.
Are you coming down there too? Will ya?
This is the first I've heard of it, so let me see if I can make it.
All right. So that's it.
Oh,
Thank
Oh,
I have a question for anyone who's planning to go down with me on Friday. Is there any, Roger, are you coming?
well, I asked you if we could ride with you, and I got a maybe. So I don't know.
Well,
Yeah.
here's the thing. Elaine and I went out today and to check the trailer and its contents, the dish, and I found out that the dish nearly flew away on the short trip back to the house. All the straps that were put on it did absolutely nothing. So I could use somebody to come over here. I have tons of straps here. We didn't have enough there. And I need help finding a way to pin that down so it'll survive a 2.5 hour, 70-mile-an-hour drive without flying out of the trailer. It's
Okay.
very aerodynamic.
Like a sailboat.
Yes, exactly. Those pedals, it's not pedals. That dish came apart in only 3 pieces, and they're very large, and they look like airplane wings.
Yeah.
Okay.
Yeah.
So anybody who would volunteer to come over here between now and Friday morning and help me tie this stuff down so that I can be sure it'll survive the trip would be appreciated.
Okay. Yeah, Roger, let's
Let's get
talk.
together
Maybe
on
we
that,
can
Bill.
do that. Also, if on the Friday trip I may need a ride down. I'm having transmission troubles in my truck, so I'm not sure I can get it fixed by then. But
Well, let me tell you what that Mamie was about. Mamie, I'm bringing Homer.
Oh.
And if I bring Homer, I need to bring Homer's trainer. And that leaves, if I put Homer all the way in the back of the truck, I still have two seats behind the driver and passenger seat. So that I think we can make this work.
Yeah.
But whoever is traveling has to be okay with Homer.
Oh,
Okay.
well, you know I hate Homer, so.
Oh, I can tell. Yeah, yeah. And he has had two very long drives today and yesterday, and he's in a very good mood now.
Okay,
He
we'll get
loves-
together on that. Bill, you and I, let's talk and see if we can get over there and
All right.
strap that down.
Yep. Okay.
Thanks, guys.
Thanks,
Anything else
guys.
before we close up?
Yeah, Alex, are you still on there?
Yes.
Okay. Do not send your transverter. I've got a 100-watt amplifier that will excuse me, 100-watt mic amplifier that will provide enough drive power for all the modules.
Okay, that sounds good then. Yeah, I don't really need it anyways because I'll be on travel till my trip to Haswell. But if you're insisting that you have it, then I'll keep it here with me. And I'm planning to pack it up everything and ship to you by Wednesday.
All right, Alex. Okay, thanks.
Thank you.
One quick thing, if you guys can hear me, I'm kind of in the middle of nowhere, so maybe not, but
Can hear you?
the weekend you guys are talking about going down there is fair weekend. So if hotels or Airbnbs are needed, I would say you need to call ahead because there may not be a room.
Okay, I'd probably stay on site. I'd probably go down there for just one overnight and stay on site. But yeah, that's a good point. Thank you, Megan.
No problem.
Is the Airbnb open yet, or is it already booked? Can
Well,
you
we
hear me,
lost
Meg?
her.
Oh, yeah, she probably dropped out. Probably on that dirt road that I lost it.
As she mentioned, she's in the middle of nowhere.
Oh, I'm back. I'm almost
There we go.
I-70, guys. Almost. What was the question, Paul?
Is the Airbnb still open?
It is as of right now. I don't expect that to be the case for much longer.
Okay. Why don't you book it for me? Or I'll just whatever.
Okay, Thursday or Friday?
Friday, Friday night, Saturday night.
Okay, I'll do it when I get home.
Awesome. Thank you, ma'am.
No problem.
Now it's
Yeah.
booked.
Yeah, and I have so just so you know, there's 2, maybe 3 beds there.
There are 2 queens in the bedrooms and then a queen sofa. So
Lots of room there,
Okay.
guys.
Maybe,
All right.
maybe I'll talk to you, Paul.
Thank you, sir. All right. Thanks, Megan. Appreciate it. Good thing you're on there. All right, guys. I think we're done for tonight, and we will see some of you guys on Friday this week. If I can get down, I'll have to. I got a couple other things that are conflict, and then on the 11th, of course, we'll be down there Friday, Saturday night.
And
All right,
tomorrow
guys.
we're gonna have a meeting, board meeting at 4 p.m. Denver time, correct?
That is a Roger, QSL.
All right. I'll talk to you guys tomorrow. Good
All
night.
right.
Thanks for putting up with all my questions, Alex.
No worries. I'll charge you later. Bye.
Okay.
All the best, guys. Have a good night.
Okay.
Thanks again for everything. Great meeting.
Thank